Hello, my name is Amy Byers, and I'm here with Brandon Wagoner, and we'd like to welcome you to Middletons Electric's Plugged In podcast. This podcast focuses on the world of electric vehicles. It is for EV enthusiasts. It's for people that are maybe just dipping their toe in the water and seeing what's out there on electric vehicles. But it's for everybody. Today, Brandon and I would like to welcome Drew Frye. Drew is the manager of electric vehicles, energy services, and programs with the Tennessee Valley Authority. And the relationship between TVA and Middletons Electric is we're one of the 153 local power providers that purchase power from TVA. So we're excited to have you here today. And of course, Brandon, he is the Middletons Electric EV guru, so he'll probably be able to talk more on the EV level than I am. I'm just interested to learn all about it and hear what both of you have to say. So tell us a little about your experience with electric vehicles, both professionally and personally. I know we were just talking before we started, and I think you drove up from Chattanooga in a Leaf, a Nissan Leaf. So you can tell us a little bit about that as well, but just kind of tell us how you're interacting with the electric vehicle world, both professionally and personally.
Yeah, so I started at TVA back in 2011, so a little over 11 years now, and I was hired into a group that really focused on just electric vehicles. And back then, 2010, kind of 2011, is when the Nissan Leaf started rolling out of the Smyrna plant. So really kind of what I will call the first generation of electric vehicles. Of course, there have been electric vehicles through the years, the EV1, and dating back to the very first vehicles out there. But I call this the first generation of electric vehicles, and to see how the technology has changed in the 11 years that I've been either tangentially or working on electric vehicles is amazing. You know, those first Nissan Leafs, they were 60 to 80 mile range cars. And the latest generation Nissan Leaf is over 200 mile range cars. So just so much has changed with the batteries and being able to put bigger batteries in the cars. So I drive a Nissan Leaf as my TVA work car. I did come up from Chattanooga and was here for some meetings yesterday, and we'll head back and hit a charger on the way back to Chattanooga to make the trip. But personally, I also drive a Nissan Leaf, and I actually drive one of the older model Nissan Leafs. It was completely dumb luck that I bought a used car before the car market went crazy and before gas skyrocketed. So I've had this Nissan Leaf, it's a 2013 for going on 4 years now. So, who knew I would buy this used car and then COVID would happen and it wouldn't drive for a while, and then the car prices would go through the roof, and then gas would hit $5, and so I get to do all my around town kind of travel. Even though I don't go into the office as much now, all my around town travel is in that Nissan Leaf, and it feels so good to wake up every morning with a full battery and think about the cost savings there. So I've been in the electric vehicle world for quite a while now.
So Drew, Amy mentioned, she said I was the EV guru for Middletons Electric, but what she doesn't realize is that everything I've learned has pretty much come from you and the research at TVA. So I guess it's funny you've been at TVA since 2011. I started at MTE in 2011, so that's funny. But we started crossing paths probably 4 or 5 years ago when you were doing some of your, I think it was Smart Charge Nashville project. Mm-hmm. And a lot of research came out of that, both about the different habits on how people were charging both at their house and at work. But there was also some research that came out about the projected growth of EVs in our area, in the state, in the valley, and the impact it was going to have on the grid. Could you talk a little bit about what those EV adoption rates look like and how TVA has come up with those numbers?
Yeah, absolutely. So I like to say there are no EV gurus unless you're building the cars or you've driven one yourself. And so really we learn by doing. And one of the great learnings that we've had over the last, I'd say 3 to 4 years, was really some of the work that originated here in Nashville with the Smart Charge Nashville project. And maybe some of the folks listening were part of the Smart Charge Nashville project. But this project was to really understand the driving and charging behaviors of electric vehicles, because understanding how the vehicles behave helps us plan for the future in how we generate and deliver electricity to everything, and everything might be, vehicles. And so we've really focused on sort of understanding things from a data-driven approach, understanding how much energy electric vehicles need, when they charge, how quickly they charge, and that sort of builds up into a forecast and a prediction of what TVA needs to do to prepare for that future with more EVs. And so on our planning side, we really kind of focus on three things. We've got some near-term goals with partners like Middletons Electric, Nissan, and other local stakeholders. We also have kind of midterm projections in how we're planning for the power system, but we also run long-term scenarios to understand what the future could be, kind of given different adoption levers.
Mm-hmm. And I know I've seen some stats about projected amount of EVs that are going to be here by maybe 2025, 2030. But how many EVs do you think are currently in the state today?
Yeah, so currently, TVA covers parts of 7 states. But it's mostly Tennessee. And when it comes to EV adoption, it's really kind of Nashville leading the way. Okay. So in the Tennessee Valley, there are about 30,000 electric vehicles on the roads today. Okay. So thinking again back in 2010, really 2011, when the Nissan Leafs and the Chevy Volts came on the scene, where you had maybe those two and maybe a Tesla Roadster were the only options. And fast forward today, where there's really kind of close to 100 different electric vehicle makes and models. And it might not be easy to find each one of them and do a test drive on a dealer lot, but online sales and things like that, there's really a bunch of different options out there. And so we've got a goal to see 200,000 electric vehicles in the Tennessee Valley by 2028. So that's kind of our near-term goal. And when we think about what TVA is doing in partnership with local power companies, it's really kind of how can we get to 200,000 EVs? And so I told you there's 30,000 today, so we're really kind of almost adding a zero as far as EV adoption goes. And so it's really kind of that first big step in EV adoption where things start to matter, where we start to talk about not ones and twos, but hundreds of thousands. In our midterm projections for how we plan the power system, we project about 1 million electric vehicles on the road by 2035. And that equates to about 30% of new car sales. Okay. So if you think about today, we're talking about ones and twos percents as far as market share goes. In 2035, we're looking at 30% of all new cars being sold being electric. And there's about 400 to 500,000 gasoline vehicles that are sold each year. So we kind of build off of those projections on what the sales will be, and then roll that up to TVA to say, well, what does that mean for TVA? What does that mean for the power system?
I have a question about that. When you're talking about how it's going to affect the power system. I know, we had a very hot June and July, and there were, we putting out, hey, we need to curtail, we need to conserve, and all of these things. And one thing I saw a lot of people commenting on, different Facebook posts we may put out or whatever, was how can you be pushing EVs when you're in the same sentence you're asking us to curtail. So I want you to talk a little bit about how does the EV affect the power system. And when we get into those, of course, we don't send out anything about curtailing. Usually we do it, twice a year in the hot of the summer and the cold of the winter. It's not something that we deal with, very often here, which we're very fortunate. Other areas of the country have a lot of problems with that. But we don't. The TVA system is very strong, and we're very fortunate. But I do want you to address that for everybody.
Yeah, so a couple of different things there. First, let's talk about those adoption numbers we just talked about, and what does that mean for the power system? So kind of that 1 million EVs on the road by 2035, that represents about 2% of growth to the TVA power system over several years. So this is very moderate growth from a TVA system perspective. We typically, look at annual growth anywhere between 0 and 1-ish plus percent. So, a 2% over a couple of years is not a need to rush out and build power plants, for example. That's specifically about those peak hours and the steps that we go through. Kind of the public appeal or the public communication of peak hours is just one step in the TVA process for how we provide power. And it's a voluntary, basically, offering up of information. And I did see a lot of stuff about electric vehicles, and some folks thought we were giving EVs a pass. So, well, you didn't say anything about not charging your EV. Well, what the messaging was trying to appeal to the most people. So we talked about things that every home has, a thermostat, a clothes washer, dishwasher, simple steps that customers could voluntarily do to shift their energy usage to off-peak hours. Right. Because really the only bottleneck, it's kind of like, I hate to say it, the traffic. Let's think about the traffic on the interstate. Certain hours of the day there's no traffic, and you zip down 24 going 70 plus. Certain hours, we know what happens. That's really kind of how the power system is too. There's certain hours where everyone's trying to use all of their energy. It's super hot outside or it's super cold outside. And folks are getting home from work and turning on the stove and starting the dishwasher, starting their clothes. And so really it's a voluntary, shifting of your energy. Basically, when the sun goes down, the power system, we ease all that traffic, to use the interstate example. And we have all of this extra capacity to do more things electrically. And so I think electric vehicles is a great example because they're basically batteries on wheels. And those batteries don't really care when you charge them unless you're on a road trip or something and it's time to recharge and get back on your way. But when you come home after work, they don't care if you start charging at 6, 7, 8, 9, as long as they're recharged in the morning. And so it's one of those things as more and more EVs get out there, you'll see that in our messaging. You'll see, talking about either programming your car or programming your charging station or just waiting a little bit extra to plug it in because all these batteries in these cars are super smart. Yeah. You can program in, start at midnight or 8 p.m. or have me charge by 8 a.m. and let the car think about it. And it backs up and does the calculation. So we're planning for kind of those, the bigger system and with our EV load projections, but there'll always be those peak hours. Yeah. And there'll always be that need to think about how we use energy in the time of the day and look for ways to make those shifts to different hours.
Yeah, well, that was the one thing I thought of when I read that. I was like, well, the majority of the people are probably charging at night. You go home, you pull in after the end of the day and you're plugging in at night when, the load has dropped off. Mm-hmm. So there's plenty of load there to, power these vehicles. It's just the understanding of, how the system works and hopefully we can get more information out there so people can really understand that, because we certainly don't want that to be a hiccup for someone who really is interested in the EVs.
Yeah, that's one of the big takeaways we learned from Smart Charge Nashville when we were looking at how folks were charging. And we were seeing, some folks coming home 5, 6 p.m. and plugging in, but in aggregate, we weren't seeing that from everyone. Mm-hmm. Some folks were charging their car every 2 days or every 3 days. Some folks were running errands after work, and they were showing up and charging at 9 p.m. and still had plenty of time to recharge in the morning. So we were seeing this diversification of charging where not everyone was charging at the same time. And that's the underlying information that we use when we look at when we'll need to provide energy to these millions of vehicles in the future.
So I want to kind of talk a little bit more about the demand and the conservation and those kind of topics. And I know I'm sitting here with 2 engineers, so I'm probably gonna dumb down electricity for me, and y'all can weigh in on this, because I think when I've read a lot of those comments about how if we're plugging in our vehicles, is it going to put too much of a strain on the system and that type of thing? And, the way that I understand it for not only Middle Tennessee Electric, but TVA, I mean, when you're deciding how much power to give us and we're deciding how to build out our system, we have to assume that we want to be able to provide power to a home that's using every bit of their electricity at one time. So they're turning on everything they've got on a normal day, and we should be able to power that. Of course, that's not how people live. You're not going to live that way. You don't have everything going in your at the same time in your home at the same time that all the schools are going and blowing and the factories are going and blowing. There's so much out there, but we have to build as if that's the case, so to speak. And so when you think about that in electric vehicles, it seems to me, and correct me if I'm wrong, that there is a lot of times where there is a lot of electricity that's not being used. And the EVs are a perfect fit for that because the power is there. I know I'm really simplifying this very, very much to the communication brain versus the engineering brain. But can y'all really both talk a little bit about that as far as the TVA system and then as far as the Middle Tennessee Electric system? And Drew, let's start with you because y'all got to get the power to us before we can do anything with it. So
yeah, absolutely. So let's think about power plants and the transmission system. So TVA makes the electricity at the power plants. We use big wires and transformers to push it to a Middle Tennessee Electric, and y'all pick it up from there and get it to its ultimate destination. So how we plan for power generation and transmission is really kind of building to those peaks like you were talking about, having that capacity there to supply the needs of everyone. And when we talk about these peak hours and being able to shift energy consumption to different hours, that's really just cost savings. It's not that the system isn't there to provide the power, but if we can, provide electricity, or if we can provide the peaks that are this, but the system's built for this, we save. We save on fuel, we save on wear and tear on the plants and the transmission system, all those kinds of things. So it's really a cost-saving measure rather than an emergency measure. And so, we pick it up from there and push it down to Middle Tennessee Electric, and y'all kind of take it the rest of the way.
Yeah, and so Middle Tennessee Electric is kind of in a unique situation. I'd say most of the TVA LPCs are in a similar situation, but I think MTE's done it a little bit above average on the way that we built our system. And I really credit our engineering team. For 20 years, anytime there was a road move and we needed to reconductor a line, they'd put up the biggest conductor possible because the cost differential wasn't that significant. It wasn't negligible, there was some difference, but the thought was let's go ahead and put up and design for tomorrow's load, not just today's. So that was great. The other thing that we've done in the same thought is every time we built a substation, even though it would be a one power transformer substation, we'd go ahead and build it for two. So the bus, the breakers, all the electronics inside the switch house they were all built out for two, and then in need of an additional load, you could double the capacity of that substation by just purchasing a power transformer, drop it in place, and close a few switches, and now you're ready to go. So that has resulted in a grid where we can take substations out, and we do this frequently. A couple of times a month we'll take a substation out. No one obviously notices because we backfeed everything. And we do preventive maintenance on all of our equipment. We do our own power transformer testing and do all this in-house to ensure the life of we get as much life out of those assets as possible. But it's been great because there's load that shows up that we weren't expecting, and guess what? We're ready to serve it with. It's hard to go back and say that there was no cost in what we did, but we can measure the savings. They're immense because we don't have to go down now and take that pole down and reclassify it for heavier wire. All that's already been done.
Yeah, I was going to say things will always change. Yeah, that's the truly interesting thing. We think how we use electricity hasn't changed, but through the years it really has, and we see a lot of parallels between the adoption of electric vehicles, kind of system growth, to the adoption of air conditioning. And so, air conditioning really came about in the late 50s and into the 60s and 70s. And you think about older homes, they weren't built with air conditioning in mind. So electric service and those things, they weren't built with air conditioning in mind, but they've been adapted through the years. And now it's standard for every home to have an air conditioner. Goodness, I wouldn't want to live in a house without an air conditioner right now. But we see EVs kind of as the same kind of thing, an adoption over the years, and just a change in how we use energy.
Well, I think when I've done a lot of energy efficiency talks over the years, and I remember there was one graph, and it had like things you plugged in the 70s, things you plugged in the 80s, and how that, now we plug in everything. And I tell people, I'm like, if you don't believe me, turn all the lights off in your house and walk around your house, because everything has a little LED light on it. You don't need night lights anymore because everything in your house has that LED light on there that's lighting up. We are plugging in everything. So I think with that in mind, I think with TVA and Middletons Electric and all the LPCs, really, you have to build for the future. You have to build for the unknown, because we don't know what technology is going to be in 10 years. I mean, think about how far we've come. Even, you were saying earlier about the EVs, the first generation 10 years ago. I remember, we had one, and drove around in it as well. And it was, from that, like you said, there was three: the Volt, the Leaf, and the Tesla that nobody could afford. So you didn't see Teslas, that much. And now they're everywhere, and every make's got one. Every car maker's got one. So, well, this has been a great discussion. I hope that it's been informative. But we want to thank you first and foremost, Drew. You're going to have to come back a couple of times, I think. I don't think we have remotely tapped into the information you can provide us. So definitely want to have you back. Thanks again to all the listeners. And for more information on MTE's Drive EV program or the EV Car Club, you can go to mte.com/drive EV. Until next time, plug in, power up, and drive safe.